Bilirubin's Little Adventure, A Tale of Jaundice. Once upon a time, in a bustling blood vessel village, lived a group of diligent little workers known as hemoglobins. Using the red blood cell boats, they travel along the bloodstream to work. Each hemoglobin wore a trusty globin cap and carried an iron backpack, specially made to hold on to oxygen during their important journeys. They spend their days joyfully collecting fresh oxygen from the alveoli forest down the stream. Using the red blood cell boat, they carried oxygen to the far corners of the organ kingdoms along the stream, keeping everything strong and healthy. One bright morning, just after harvesting a fresh batch of oxygen, disaster struck. A swarm of sticky, invasive creatures called Mycoplasma haemophilus attacked the village. Mycoplasmosis is caused by Mycoplasma haemophilus. They are epi-erythrocytic parasites. They are transmitted through arthropod vectors such as lice, ticks, flies, and mosquitoes, vertical transmission in cats, and blood transfusion. They latched onto the red blood cell boats, poking holes and multiplying rapidly. Panicked, the hemoglobins called for help. The white blood cell soldiers quickly arrived. Lymphocytes fired precision-targeted antibodies. And soon, hemoglobins with their broken bones arrived at the spleen. The mighty macrophages joined in, smashing the invaders with powerful blows. IMHA, also known as immune-mediated hemolytic anemia, occurs when Mycoplasma haemophilus attach to RBC membrane and form PEDs. Hemolysis occurs intravascularly due to antibody and complement attachment to damaged RBC surfaces, and also extravascularly due to recognition and phagocytosis by reticuloendothelial system. Though the enemy was defeated, the battle took its toll. The red blood cell boats were shattered. In IMHA secondary to mycoplasmosis, the hematological findings are macrocytic, normochromic, highly regenerative anemia with the presence of ghost cells and spherocytes. Losing their boats, hemoglobins escaped. In the panic, they dropped their globin caps and even lost their iron backpacks. Stripped of their purpose, they transformed into lost and wandering bilirubins. Macrophage breaks down hemoglobin into its component, where heme were converted into biliverdin by heme oxygenase, and further broken down into bilirubin by biliverdin reductase. Thankfully, the body had a rescue system in place. The albumin transporter, a strong but silent raft that picked up the bilirubins and carried them through the bloodstream in search of a new destination. Why do unconjugated bilirubin need albumin? Unconjugated bilirubin is not water-soluble. It is solubilized by reversible non-covalent binding to albumin in order to be transported in the blood. But there were too many of them. With the red boats destroyed faster than they could rebuild, bilirubins began to accumulate in the bloodstream. The kingdom was no longer in balance, showing signs of prehepatic jaundice, and the journey of the bilirubins had only just begun. In the blood, there were unconjugated hyperbilirubinemia and hemoglobinemia. In the urine, there was hemoglobinuria, and in the feces, it is brown in color due to normal production of stercobilin. The bilirubins floated through the bloodstream on their albumin raft until they reached the great fortress of liver. The fortress had towering walls, but the bilirubins were small and could slip through the narrow carrier protein gates. Bilirubin uptake by hepatocyte occurs when the bilirubin-albumin complexes pass through the fenestrations in the endothelium lining of the hepatic sinusoids into space of these. The bilirubin dissociates from albumin and is taken up by a liver-specific carrier protein, also known as the organic ion transporting polypeptide or OATP transporter. The kind citizens of hepatocytes welcomed them in. They were offered glucuronic acid jackets and cozy huts to rest in, preparing them for safe travel through the bile duct tunnel, their new pathed home. Conjugation of bilirubin occurs when unconjugated bilirubin binds to proteins in cytosol. UDP glucuronyl transferase solubilizes bilirubin by conjugating it to glucuronic acid, forming bilirubin monoglucuronide and diglucuronide. Conjugated bilirubin is now hydrophilic and is ready to be excreted into bile. For a while, the bilirubins felt safe again, but danger was never far. One gloomy day, pirate ships appeared on the horizon, fearsome bacteria named Escherichia coli sailing up the portal vein. They stormed the fortress, releasing clouds of nauseous green gas that poisoned the hepatocyte huts and left many ill. Escherichia coli is a gram-negative fraud bacteria that constitutes the intestinal microbiota of animals and is an opportunistic pathogen. E. coli releases lipopolysaccharide or LPS endotoxin that causes hepatocyte injury by degrading microsomal enzymes, impairing mitochondrial functions, and stimulating release of mediators like lysosomal enzymes and collagenase from Kupffer cells. In a flash, the neutrophils, brave first-line defenders, marched into battle. Neutrophils fought fiercely, pushing the pirates back with all their might. Hepatocyte huts grew bigger and bigger, putting the fortress of liver into an emergency condition, hepatitis. This condition is known as neutrophilic cholangiohepatitis. It is often associated with inflammatory bowel disease and pancreatitis, also known as feline choroiditis syndrome. Inflammation of the liver results in hepatomegaly. Neutrophilic left shift and toxic changes are evident in CBC. The walls of the liver thickened and the carrier protein gates narrowed and shut. The bilirubins waiting outside the gates were left stranded. Some were pushed back into the bloodstream, increasing bilirubins even further. Others squeezed into the bile duct tunnel, hoping to find an exit. This led to hepatic jaundice, caused by a bottleneck inside the liver itself. The system was failing under the weight of infection and inflammation, and the bilirubins had nowhere safe to go. In the blood, there were unconjugated and conjugated hyperbilirubinemia, elevated ALT, AST, ALP, and GGT. In the urine, there was bilirubinuria. In the feces, the color ranges from brown to clay. Deep within the dark and twisty tunnel of the bile duct, the bilirubins tiptoed carefully, hoping this final passage would lead them to peace. but the path grew darker and narrower with every step. The process of bilirubin release into the bile occurs when the hydrophilic bilirubin diffuses to the canalicular membrane to excrete into the bile canaliculi. Conjugated bilirubin is transported across the canalicular membrane by the MRP2 via ATP-dependent process. Just as they reached the tightest band, they spotted something dreadful. A giant slumbering fluke named Platinosomum consinum. Its cold body pulsing with slow, heavy breaths, blocking the way. Platinosomum consinum is a hepatobiliary fluke. It is transmitted through ingestion of infected intermediate hosts such as lizard, gecko, skink, and frog. But with a sudden roar, the beast awoke. It thrashed and writhed, blocking the way completely. This causes cholestasis secondary to hepatobiliary fluke infection. Young flukes emerge in the intestine and migrate into common bile duct, gallbladder, or hepatic ducts. They mature within 8 to 12 weeks into adult fluke, causing inflammation and distension of the bile duct. Thickening of the bile duct and blockage of bile flow occurs, leading to biliary fibrosis. Terrified, the bilirubins ran. Some forced back into the now damaged fortress of liver, others swept into the bloodstream once more. The blockage causes bile to build up and bilirubins flooded the system. This was post-hepatic jaundice, a devastating end of their journey. Every pathway had failed. The organ kingdoms turned more yellow than ever before as bilirubins overwhelmed the body's defenses. In the blood, there were conjugated hyperbilirubinemia, elevated ALP and GGT. In the urine, there were bilirubinuria and negative urobilinogen. The feces turned pale grey or acholic, with the presence of steatorrhea. And so, the once purposeful hemoglobins, now aimless bilirubins, wandered the body, building up in the blood, in the skin, and in the whites of the eyes, turning everything a deep golden yellow. The tale of the bilirubins is still told across the organ kingdoms. A story of loyalty, loss, and the delicate balance that keeps the body in harmony. Only by treating the true source of the chaos, the invading mycoplasmas, the raiding pirates of E. coli, or the lurking flukes, can peace be restored, and the hemoglobins return to their rightful place, once more breathing life into the body.